Good morning, students. We are doing unit and dimension. Today we will see type 3 problem. Let's see. Distance covered by a particle x is equal to a plus bt plus ct square. Find out the dimension of a, b and c. So let's see. This x is distance. So individually these three terms will be also distance. Why? Because we know that only the same quantity we can add or subtract. Understood? Suppose if I say one cat plus one dog, how many cats, how many dogs? You can't say because these two quantity are different. But if I say one cat plus one cat, how many cats? You can easily say two cats. Understood? So if this x is distance, so individually these three terms will be distance. So we can say a is equal to distance means dimension will be L, and bt also distance, so dimension L. Now t is equal to time t, so b is equal to L by t, L t to the power minus 1. This is the dimension of b, and ct square is equal to also L, so c is equal to L by t square, L t to the power minus 2. This is the dimension of c. Very easy. Understood? Now problem 2. The equation of a gas, this is the gas equation. We have to find out the dimension of A and B. Let's see, this P is pressure, so it will be also pressure, A by V square. A by V square is equal to pressure, and we know pressure means force by area, force by area. So already we know the dimension of force, mLT to the power minus 2, and the dimension of area, L square. Now we know the dimension of volume, L cube, it's a square, mLT to the power minus 2 by L square. So L cancel, A by L to the power 6 is equal to m t to the power minus 2 by L, on L cancel, L to the power 5. So A is equal to m L to the power 5 t to the power minus 2. This will be the dimension of A. And now this is volume. So individually this B will be volume. So we can say the dimension of B is equal to volume means L cube. So this is the dimension of A, this is the dimension of B. Understood? Now problem number 3. Let's see. position of a particle y is equal to a sin omega t. Find out the dimension of omega. You have to find out the dimension of omega. So let's see. This is like theta, sin theta, cos theta. This is like theta, means this is an angle, and we know angle always dimensionless. Angle always dimensionless. So we can say omega t has no dimension, means m to the power 0, l to the power 0, t to the power 0. This means actually 1. M to the power 0 means 1, L to the power 0 means 1, T to the power 0 means 1. So 1 into 1 into 1 means 1. And the dimension of T is equal to T. This is 1. So omega is equal to 1 by T. T to the power minus 1. This is the dimension of omega. Understood? This is type 4 actually. This is type 4. Type 4, question number 2. Position of a particle y is equal to a sin omega t minus kx, where x is equal to distance. Find out the dimension of omega and k. This is the question. Position of a particle y is equal to a sin omega t minus kx, where x is equal to distance. You have to find out the dimension of omega and k. Now this is like theta, so this is dimension less because this is angle. So individually omega t will be dimensionless. So we can write omega t is equal to m to the power 0, l to the power 0, t to the power 0 means 1. So this t will be t. So omega is equal to 1 by t means t to the power minus 1. This is the dimension of omega. And this is also dimensionless. Kx is equal to m to the power 0, l to the power 0, t to the power 0. X is distance. So it is given in the question. So distance dimension will be L is equal to 1. So K is equal to 1 by L means L to the power minus 1. This will be the dimension of K. Now type 5. Type 5. Position of a particle y is equal to position of a particle x is equal to v naught by b Let's see. Position of a particle means it is distance. Position of a particle x is equal to v naught by b into 1 minus e to the power minus bt. You have to find out the dimension of v naught and b. Let's see. Exponential function. This is exponential function. So exponential function, mind it, exponential function always dimensionless. Exponential function always dimensionless. So we can say bt has no dimension, means m naught l naught m to the power 0 l to the power 0 t to the power 0. This t is time t, this is 1, so b is equal to 1 by t means t to the power minus 1. This is the dimension of b. Now this is distance. Position of a particle means distance. So individually, if we multiply this term with this, we will get two terms, v naught b minus v naught b minus e to the power minus bt. So individually, v naught by b will be distance. So we can say L, and already we have got the dimension of b. So putting this value here, v naught by t to the power minus 1 is equal to L, v naught is equal to L t to the power minus 1. This is the dimension of v naught. Understood? We are doing type 5 problem. Type 5. Pressure P is equal to alpha by beta. exp means e to the power. exp means e to the power, exponential function. Let's see the question. Pressure P is equal to alpha by beta e to the power this. exp means e to the power. Find out the dimension of alpha and beta. We have to find out the dimension of alpha and beta. Where z is equal to distance, it is given, theta is equal to temperature, kb is equal to Boltzmann constant. What is this? You will learn about this kb in future. I will teach you in details in future. So now Kb is Boltzmann constant, and Boltzmann constant is equal to R by Na. What is R? R is equal to universal gas constant. Pv is equal to RT. You know this equation you have learned in class 10. Pv is equal to RT. This is the ideal gas equation where R is equal to universal gas constant and Na is Avogadro number. A means Avogadro, Na means Avogadro number. So R by Na we can say it's a constant Kb and B for Boltzmann constant, that's why. So now come to the point. P is equal to alpha by beta into e to the power this. This is dimensionless, no problem. And we know P is equal to force by area. So this term will be alpha by beta will be force by area. So we can say alpha is equal to force. Force means ml t to the power minus 2. The dimension of force ml t to the power minus 2. This is the dimension of alpha. And beta is a similar beta is similar to area. So dimension of area L square. So dimension of beta will be L square. Understood or not? This is type 5. Now type 6. Type 6.